Alright, so we are left off with organic naming of alkanes, alkenes, alkynes. The next one we want to go over is aromatic hydrocarbon. So I put in parentheses what that basically means. We're focusing on a ring. So we call it cyclic, not necessarily it's always going to be circular, but cyclic means that you've connected a long chain of carbon. The molecular formula for the specific aromatic hydrocarbon, again, carbon-based chemistry connected with hydrogen, is CnH. What that means is that we would have a molecule, and I'll draw it right here so it's not confusing, is that we would draw the molecule with 6 carbon and 3 double bonds. That would leave us with the same amount of carbon and the same amount of hydrogen. So it's every other one. The way we would name this is we have 6 carbon, which is hex. We have triple bond, which is double bond, excuse me, which is hexene. We need to start counting. When a cyclic, we just count at the first or double bond or the first triple bond or the first area that they have that gets the lowest number. So there's a 1, I'm going to start there, 2, 3, 4, 5, 6. So we have a 1, we have a 3, commas between the numbers, we have a 5. So at 1, 3, 5 we have a double bond. So what we're going to have to do is that we actually have 3 double bonds. So then we are going to include the prefix 3 in between that word, indicating, reiterating basically, how many double bonds we have. Because this is cyclic, we can't merely write this out because this would make it look like it's a long chain. We add the word cyclo in front of anything that's connected in order for it to be connected. So in this case, cyclo-1,3,5 hexatriene looks like this. We can also simplify that, I'll put a little sign like this, by just drawing out the lines. So at each of these corners there's a carbon, and these represented. We know that there's hydrogens because this is a hydrocarbon. And then lastly, we could also shorthand it even easier by showing the double bonds with a circle. So we can use any of these to show what this molecule is, cyclo-1,3,5 hexatriene. It is also known as the benzene ring. That's another alternative way of saying this aromatic hydrocarbon. If the benzene is its main name, it's used as benzene, or you can use the long name. If it's used as a branch off of a long chain of carbon, then you would actually add the YL ending to indicate that it's a branch. So we will go into how to name branches with examples that we do. All right, let's move on to the last category before we start doing examples. Halogen derivatives. You need to remember what a halogen is. It's the group that is second to the right, to the end on the periodic table. So they border the noble gases. They're the ones that have 7 valence electrons and a -1 charge. They're chlorine, bromine, iodine, fluorine. Any halogen, what happens is that instead of using the branch name with YL, you add O. So for example, it would be chloro, fluoro. Let's do an example just so we have it of a halogen derivative. I'll put 3 carbon here and a chlorine atom attached to it. Notice that even though I'm not drawing the hydrogens, they are present, and we need to know that they are, but this is a shorthand way of drawing them. So there's 3 carbon. 3 carbon is prop. A good way to remember the first 4 prefixes of meth, eth, prop, and bute is perhaps saying Matthew eats peanut butter, kind of a way to help you remember that. So these are all single bonds, which means that ending suffix of ane, which we learned that in the previous video. There's a chlorine atom on one of the carbon. So if you counted left to right, the chlorine atom would actually be on number 3, but we need to give that the lowest number, so we start counting from right to left. So on the first carbon, we have a chlorine atom. We say chloro. There doesn't have to be a space between these two, but there should be a dash mark between the number and the letter. So 1 is indicating where chlorine is found. We're using O because it's a branch off of your main chain, the longest chain possible. Let's start with a couple practice problems. Got some here. All right. Notice that there are straight lines, and in the real world of organic chemistry, we would see angles. However, since we're learning, let's start with some basics. Let's do this one right here. You can pause this video at any time to write these examples down in your notes. So we have to count, the first thing, count the longest chain possible. So without picking up my pen, what is the longest carbon chain? Here I have 4. If I curve it, it's still 4. If I go from right to left, curve it, it's 4. So it looks like no matter how I go, I've got 4. For this one, I'm going to show that it doesn't matter if I curve it or not, as long as I didn't pick up my pen or pencil. So 4 is my longest one. I'm going to give a prefix of 4, which I need to have memorized, which is bute. Looks like but it's not. It's bute. I have bute, and they're all single bonded, so I'll have butane. You'll notice that I have these branches that are branched off of the main chain. They are 1 carbon each. The prefix for 1 carbon is meth. So I'm going to just jot down this meth everywhere. There we go. The branch portion indicates, the YL indicates it's a branch portion, so I actually have a methyl, methyl, methyl. So it's pretty wordy to say methyl, 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 butane. And then still you have to indicate where these methyls are. So what organic chemists like to do is say, okay, if I have 4 methyls, I'll put the word methyl here, I'm going to indicate what an inorganic chemistry notion, because that's representing number, and then I'm going to indicate where they're located. I can count right to left and left to right in a group of 4. It doesn't matter. So at number 2, I have a methyl group. On the other side of 2, I also have a methyl group. On 3, I have a methyl group. And on the other side of 3, I have a methyl group. Remember the dash mark between your numbers and letters? So you are reiterating what tetra means. If you wrote tetra, there should be 4 numbers. So this molecule is butane as the main chain, or main longest chain of carbon, with branches of methyl groups attached. So 2, 2, 3, 3 dash tetra methyl butane.